All right, in this explainer, we're going to tackle something called climate tipping points. Now, I know that sounds a bit scientific and abstract, but trust me, it has some surprisingly real-world consequences, as you're about to find out.
So let's just start with a kind of strange question. Could melting ice way down in Antarctica actually make your flight, say from London to New York, take longer? I know it sounds completely disconnected, right? But stick with me because the answer is pretty fascinating.
Okay, so to get to the bottom of that whole flight time mystery, we first have to unpack what a climate tipping point actually is. Well, the Met Office has a pretty solid definition. They call it a critical threshold. And once we cross that line, the whole system can just shift in a really big and often irreversible way. It's basically the point of no return, where one tiny little push can trigger a massive, long-lasting change.
And honestly, the best way to think about this is to picture a huge line of dominoes set up all across the planet. You just have to push one over, and you could set off a whole chain reaction.
And this map, wow, it really shows you just how many of these potential dominoes are out there. Scientists usually lump them into three big categories. So in green, you've got the carbon cycle dominoes, things like the Amazon rainforest dying back. Then in blue, that's the cryosphere, which is just a fancy word for all the ice, like the massive Greenland ice sheet. And finally, in red, you see shifts in huge climate patterns, like the ocean currents that pretty much control our weather.
Okay, I know what you're thinking. These are massive, global systems. What does something happening thousands of miles away in the Amazon or Antarctica really mean for someone living in, say, the UK? Well, let's bring it home and look at the local impacts.
Yeah, you might think the Amazon is a world away, but believe it or not, its health, its ability to soak up all that carbon, could actually change the pace of warming right here at home.
This table does a great job of connecting the dots for us. I mean, look at this. If the Amazon rainforest tips over, that could add an extra 0.3 degrees Celsius to global warming. Or, how about this one? A weakening of that big Atlantic Ocean circulation, scientists call it the AMOC, that could lead directly to more brutal winter storms hitting the UK.
But let's really zero in on that first one, the West Antarctic ice sheet. The crazy fast melting that's happening down there, that is not just some remote problem. It has very real, direct consequences for coastlines everywhere.
How real? We're talking about a potential sea level rise of 2 meters. 2! Now that's the high-end prediction for the UK by 2100 if that ice sheet really starts to go.
And a change that big, well, it would directly threaten massive infrastructure projects. Think about the Thames Barrier. The thing that protects London from flooding? Yeah, that would be under serious threat. Okay, so rising seas. That's a pretty direct consequence we can all wrap our heads around. But now, let's get back to that more surprising, almost weird connection we started with. Why on earth your flight might be getting longer? And this isn't just speculation. Dr. Paul Williams from the University of Reading puts it perfectly. He says, aviation is itself susceptible to the effects of climate change. So, how does that actually work? Well, it's basically a three-step process. Step 1, the climate gets warmer, which actually makes the temperature difference between the superhot equator and the freezing poles even bigger. Step 2, that bigger temperature difference acts like an engine, and it powers up the jet stream, those super-fast winds high up in the atmosphere that blow from west to east. And finally, Step 3. That means your plane going west has to fight against a much stronger headwind. And it turns out you spend more time fighting that headwind than you save getting a nice push on the way to Europe. And the final result? At first, it doesn't sound like a huge deal. On average, it adds about 1 minute and 18 seconds to a round-trip flight across the Atlantic. But when you start to scale that up, the numbers get absolutely staggering. Think about it. Just on the super busy London to New York route, that tiny delay adds up to 2,000 extra hours of planes in the air every single year. And of course, that has a real cost. How much? We're talking an estimated $22 million. That's how much extra it costs airlines just in fuel every year. A direct hit to the wallet, all because the jet stream is changing. So there you have it. A change happening way up in the atmosphere has a very real and very personal impact. But here's the most important piece of the whole puzzle. These tipping points, they don't happen in a vacuum. They can actually trigger a cascade of other changes. And this is where that domino analogy we talked about becomes so important. Scientists call this cascading effects. It's exactly what it sounds like. One tipping point gets crossed, and that triggers another one, which then pushes a third one over the edge. It's one domino knocking over the next and the next. And here's a really mind-blowing example of how the Arctic and the Antarctic are connected. So meltwater pouring off the Greenland ice sheet can actually weaken that big Atlantic Ocean circulation. Okay, fine. But that, in turn, helps warm up the Southern Ocean, which then, you guessed it, makes Antarctica melt even faster, at the complete opposite end of the planet. It is a literal planetary-scale chain reaction.
So, we know these global dominoes are connected. We know they're linked in all these complex and powerful ways. The really big question now is, which one is going to fall next?